There are several disadvantages using the borrow method to compute the subtraction. So the first disadvantage is it doesn't work if x is less than y. That is, let's say you're trying to do x minus y, and if x is less than y, the method doesn't work. The second disadvantage is the hardware required, or the hardware to design binary subtraction using borrow method, is going to be a lot more difficult. It's going to occupy a lot more space compared to your other methods for designing binary subtraction. So it's very crucial to come up with a different methodology to represent negative numbers. Primarily, there are three methods to represent negative numbers. The first method is the sign and magnitude method. Then we have the ones complement, and finally we have the twos complement. In modern processors, we use the twos complements method, but it is very important to learn about all the three methods. Let's go with the sign and magnitude method. In sign and magnitude, we assign a sign, or we assign a bit for representing a negative number and a positive number. Let's take an example to understand this. I want to represent the following decimal number into binary. So the decimal number is 61. Let's try to make it into binary. In binary, you know that the weight of the least significant bit is 2 raised to 0, or a 1, followed by 2, 4, 8, 16, 32, and so on. So decimal 61 would be 32 plus 16, which is 48. 48 plus 8 is 56. 56 plus 4 is 60. I cannot really use a 2 because it goes past the number, so I can use a 1 and it becomes 61. Okay, now this is a positive 61, so I'm going to use an additional bit to the MSB, and since it's a positive number, I put my sign bit as a 0. So this is known as the sign bit, and this is the magnitude. So your sign is a 0 if the number is positive. Now let me represent the number negative 61. So we first put the sign, which is a 1, and then we give the magnitude, which is the same as above. So if it is a 1, sign bit is a 1, it indicates that it's a negative number. So this is the sign and magnitude representation. There's a problem with this representation because let's try to do 5 minus 5, okay? 5 minus 5. So this is basically 5 plus minus 5, right? So what is 5 in binary? So 5 is 1, 0, 1, and the sign bit is a 0 because it's a positive number. Minus 5 would be 1, 1, 0, 1. So sign and the magnitude. Let's try to add it up. So 1 plus 1 is 0 carry 1, 1, 0 carry 1, 0, and let's ignore the carry out. Even if you ignore the carry out, you see that you are not getting a 0 result. But if you do the decimal calculation, 5 plus of minus 5, you get a 0. So you see that they are not matching up. So sign and magnitude is a very bad method to represent negative numbers.